Unit 2A, Lesson 1, Rational Exponents. In this lesson, we're going to use the same ideas we talked about earlier in the year when dealing with integer exponents, simplifying those exponential expressions. The process is going to be the same. Now we're just going to deal with fractions in the exponents. Before we get into simplifying those exponential expressions, we need to relate radicals to exponents. So if we're given an expression that's written in rational exponent form, how to rewrite that as a radical, or vice versa, write a radical as an exponent. So here's our general rule we're going to use. If we have the nth root of x raised to the n power, this value of n, the root we're taking of the radical, is called the index. All you have to do is take this index, and that becomes the denominator of the fraction for your rational exponent, the fraction you have as your exponent. So we just have a couple examples we want to go through, rewriting this radical in an exponent form for the first one. So we have the fourth root of x cubed. If I want to rewrite this as a rational exponent, get rid of the radical, this fourth root, the index of 4, just becomes the denominator of the fraction. So I would rewrite this as x raised to the 3/4 power. Now in the second example, we have a fractional exponent. We want to rewrite this in radical form. So our denominator 8 is going to become the index on our radical. So we're taking the 8th root of x to the 5th power. So that's how you rewrite expressions from radical form to exponential form, or from exponent form to radical form. Now we're going to work on simplifying rational exponents. So we're using the same ideas, the same properties we did earlier in the year when dealing with integer exponents. If we have a power to a power, we're going to multiply. If we're dividing with the same base, we subtract the exponents. Anything raised to the 0 power is 1. All of those same properties. Now we're just going to work with fractions. So for the first example, we have x to the 4th raised to the 1/3 power. So I'm just taking 4 times 1/3. This is the power to a power property. So multiplying a fraction, if this is the same as 4/1 times 1/3, numerator times numerator, denominator times denominator. So this would become x raised to the 4/3 power. And just leave that as an improper fraction. Do not write a mixed number or a decimal. Leave it as an improper fraction. In the next example, we have x to the 3/4 times y squared, all divided by x to the 1/4 divided by y. So if we're dividing with the same base, we subtract the exponents. So I'd have 3/4 minus 1/4. I'd get x to the 2/4 power, and then times y to 2 minus 1 be y to the 1st power. Now I can simplify this fractional exponent. This would become x to the 1/2 times y. Now to the last example, we have x to the 1/4 power times x to the 1/3 power times x to the 1/10 power. So if we're multiplying with the same base, we have to add our exponents together. We have to remember that if we're adding or subtracting fractions, we have to have a common denominator. So this problem will be a good review of finding the least common denominator for a set of numbers. So the first thing we should do is write the prime factorization for each of the denominators of our fractions. So the prime factorization of 4 is going to be 2 times 2. The prime factorization for 3 is just 1 times 3. We don't have to write the 1 in there. And then the prime factorization for 10 is 2 times 5. So if we're looking for the least common denominator, we have to take each of these factors and write the number of times that occurs the most in any of our denominators. So for instance, if we start with the 2, this factor 2 occurs twice for our factor 4. In 3, it occurs 0 times. In 10, it occurs once. We have to take the most it occurs in any of those factors. So it occurred twice, that was the most. So our least common denominator needs 2 factors of 2. Now we move on to the factor of 3. It occurs 0 times here, once here, 0 times here. So the most it occurs in any single number is once. So we need 1 factor of 3. Now we go to 5, it occurs 0, 0 once. Most it occurs in a single number is once. So we have 1 factor of 5. So now if we take 2 times 2, we get 4. 4 times 3, we get 12. And then 12 times 5, our least common denominator is going to be 60. So now we rewrite each of these denominators. To get the 4 to 60, we'd multiply by 15 over 15. So that becomes x to the 15 over 60. For the second part, we'd have to multiply by 20 over 20, so we get 20 over 60. And the third one, we multiply by 6 over 6 to get 6 over 60. So now we can add the numerators together because we have a common denominator. 15 plus 20, 35. 35 plus 6, we get x to the 41 over 60 power. So in this lesson, first we reviewed or talked about how to rewrite radicals as exponents or exponents as radicals, and then we went through those properties of exponents that we talked about earlier in the year. Now we just applied them to rational exponents. Make sure if you're adding or subtracting fractions, you first get a common denominator.